So in number 23, does anybody have like a one method to use because it would be easier? Virginia?
I used substitution because it already has what y is.
Yeah, because y is already by itself. Substitution works pretty easily because it's already in y equals form. So substitution says you take that expression, you plug it into the other equation for that variable. So right there's the y, so we would plug it in for y. And that gives us negative 3x minus 1. In place of y, and then that's equal to 18. So you're keeping the 2x, the plus 3, but instead of y, we're replacing it with negative 3x minus 1. And then we just solve to combine our x's. That's the variable that we have here. So that would be a minus 9, a minus 3. And then, Virginia, if we combine the x's, take the number to the other side, what do we have?
I got negative 7x equals 1.
So x is
Negative 3.
negative 3. So x is negative 3. Is that your final answer? No. Because if you're solving a system are where like the two lines connect, they cross. That has to be an ordered pair. So it's not just an x, but it's an x and y. So if you know x is negative 3, go back and plug it in. So negative 3 times negative 3 plus 1 would give us the y value of 10. So the ordered pair where the two lines cross would be a negative 3, 10. Questions? All right, so I was going to do 43, but are there questions prior to 43 that you'd like to go over? 25?
What is that?
It's a good question. So 25 says, how would you classify the system? So my suggestion would be first to solve it, and then Caitlin.
Oh, I was just going to say that on 23 you have it as negative 3.
I have it as what?
You have it as a
Yes.
positive one instead of a negative one. On the right, it's on the top.
Yeah, like on the answer sheet it's negative 3.
So
Oh, right here.
it's,
Yeah.
instead of y equals 10,
Oh.
it should be y equals 10.
I'm sorry. Thank you. Okay. Hi. Thanks. Thank you. I appreciate that. Okay. So for number 25, solve the equation, and then you're going to use the answer to decide which one of these fits. And this would be like none of these because in multiple choice there are usually 4 options. So if a system is consistent, what does that mean if a system is consistent? So it's either consistent or inconsistent, and then the consistent has the 2 different options. Okay? Right, so inconsistent is when your lines don't cross. Inconsistent would be when there's no solution, or the lines are parallel. So there's not an answer. So if there's not an answer, then your problem would look like 0 equals 5, negative 3 equals 7, something like that. So your answer is not going to be a true statement. Therefore, it's inconsistent. So there's not a solution. They don't cross because they're parallel lines. Consistent means there is a solution. And then there's 2 different options for consistent. It could be independent or dependent. Virginia?
Is it the same line?
Right, so if it's consistent, it means there's a solution, and they are the same line. So we always said that was infinitely many solutions. It's dependent because all of the answers on one line, are you okay? Okay. Depend on the other line connecting with it. So when it's the same line, if you're solving it, you usually get 0 equals 0. That's when it's infinitely many solutions. When it's consistent and independent, there's just one solution. So there's one solution, they cross once. I'll just put up here one solution. So independent, they cross just at one point. Dependent means it's the same line, so every single point on one line attaches to all of the other points in the second line. And that usually is when you have 0 equals 0. So no solution would be like 0 equals 5, 0 equals 15. One solution would be when you have x equals a definite value. So this is one solution right here, -3, 8. This will be consistent and independent. There is a solution, there's just one solution or one answer. So you need to first solve this, and then once you look at your answer, that answer is going to decide, is it A, B, C, and then really D couldn't be an option. I mean, it's going to be one of those three. Questions on that? Sam?
Read number 24. I don't know how to do that.
Number 24? Well, how would you solve it? I mean, we did 23,
Yeah.
so what's the other method then you could use to solve it?
Substitution. I forget how to do this.
This, like, number 23 was substitution.
Oh, not substitution. Oh wait, I did 23 other Could you do elimination?
Yeah, so I would suggest using elimination for number 24. If you use substitution, you're going to end up getting fractions in the problem. And generally when you get fractions in the problem, it makes it a little more tricky to solve. David, how would elimination work?
Well, you can multiply by 3 to the bottom and 2 to the bottom.
So multiply by 3 on the top and 2 on the bottom. Question? Did you have a question?
I was just gonna say
Say.
I was just gonna say do number 28.
Oh, okay. All right. So if we multiply by 3 on the top, 2 on the bottom, oh, 58. And then David, what do you do with those two equations? You subtract them. Yeah. Kate, question.
Are you multiplying the bottom equation by -2?
Yeah.
Well, so you could multiply it by -2, or David said he's just going to subtract the bottom equation, which is the same effect. So if you multiply it by +2, you're then subtracting the entire bottom equation, which means that this turns to positive, this becomes negative, and that becomes negative. So it means the exact same thing, it just depends how you were taught when you learned the substitution, who you had as a teacher could have taught it one way versus the other. So David, if we combine these together, 21 minus a -4 becomes 25x, 6y minus 6y is gone, and then 33 minus 58 is -25. So x is equal to a -1. So with elimination, the goal is for the x or one of the variables to cancel. So 6y minus 6y cancels. Ethan, question?
-20. Oh, never mind.
After you find x, you go back, plug it in to get y. So 7 times -1 plus 2y equals 11. So this becomes a -7, so we would add 7 to give us 18. So y would be 9. -1 and 9. So substitution you use when you have a variable by itself or a variable that doesn't have a coefficient in front. Elimination you would want to use when all of the x variables, y variables have coefficients in front of them. So David, you said question 28? Yes? Is that what you said? So in 28 it was a matrix problem. And this one wants you to solve for x and y. The x and the y are inside the matrices. What did you think about doing first, David? Yeah, so let's distribute the 2 through that second matrix. Alright, so if we distribute the 2 through, we end up getting 10, a -2, a -14, and a 12. Again, our goal is to find the x and the y. What else would we do? Sam?
Could you then combine these two matrices on the left side?
Yeah, so if we combine them, we have negative 2x plus 10.
You get negative 2x plus 10, then you get 4, then you get negative 13, then you get 4.
Good, nice, Sam. And then on the left, or the right side, it's just negative 9, 4, negative 13, and y. So, Sam, how could we find the x and the y?
Well, y would just equal negative 13, wouldn't it? Or no, y would just equal 4.
Right,
Sorry.
so
Yeah.
the 4 and the y are in the same position. So those elements are the same.
And then x would equal negative 1/2. Because it would be negative 2x plus 10 equals negative 9. Then you would, and then you subtract 10 from both sides. And then it would be negative 2x equals negative 19. And then the x equals 19/2.
Good. So distribute the 2 through, add the matrices together on the left side to get one matrix, and then you're just setting like the element equal to its corresponding element in the other matrix. So they match up together with the equation. So one element is equal to another element.
Would you put this in order?
You would not put it in an ordered pair. That's a good question. Because they aren't, like, it's not a line. So it's not two equations of a line that you're solving for. So you're just finding an x, you're finding a y. They're just separate solutions, separate answers. Questions? Truth. 27. So 27 is exactly the same truth. So you're just taking 3x and setting it equal to negative 18. You're taking the negative 4 and setting it equal to 2y. So you don't have to do all the extra stuff. So you're just matching the corresponding elements together. So two separate equations and then solve for each equation. So solve for the x, solve for the y. The matrices, you can use the calculator to do those. So it tells you can use your calculator. You really don't need to have any work for those. The answer to number 30 is on the board. So please make sure you're checking the solution to number 30. What I had on the answer sheet, I don't even know where I got that answer from because it's not even a 2x2 matrix. It happens sometimes. So this would be 3 rows by 2 columns. This is 2 rows by 3 columns. When you're multiplying, remember the inner numbers have to be equal in order for the multiplication to occur. So then your matrix C would be the 3 by 3. That would be the outside matrix. But you can just plug that in your calculator. And that's with the matrix button. So that's second x negative 1 on your calculator. Again, the solution to number 30 is up on the board. Virginia.
I just want to make sure it was 26B and solved.
26b was
Was it
cannot be solved, right? Because the dimensions, those middle numbers are not the same when you take b times a. Yeah. So the dimensions are not equal. Sarah?
we go over 32.
So number 32 says find the following information for the parabola x squared minus 6x minus 16. Axis of symmetry. Do you remember the formula for the axis of symmetry, Kate? Negative b over 2a. So a, b, c. Kate, that means negative b is? 6. A is? 1. And 6 divided by 2 is? 3. So the axis of symmetry is 3. That's the line that cuts the parabola in half. In order to get the vertex, what do you have to do?
Plug in 3 for x in the equation.
Right, so the vertex is an ordered pair, and the first number of that ordered pair is the axis of symmetry that we just found. So then we take that 3 and you plug it in. So 3 squared, negative 6 times 3 minus 16. So this is 9 minus 18 minus 16. Anybody know what 9 minus 18 minus 16 is, Ethan? Negative 25. So now you have your vertex. So you found x by using the axis of symmetry. That's the x of the vertex. You take that x, you plug it in, and you get y. So y is negative 25. skipping the x-intercept for a moment here. How do you find the y-intercept?
Okay, let's see.
It's c. So this one, the y-intercept is 0, c. So c is negative 16. How do you know if a parabola opens up or down?
If it's negative or positive.
Right. That first number, is it positive or negative? If it's positive, it goes up. If it's negative, it goes down like the frown. So this one is positive, so it goes up. So the x-intercept, I kind of skipped over this one. If you're finding an x-intercept, what is the y value equal to for an x-intercept? 0. So if I set this equation equal to 0, we'd have x squared minus 6x minus 16. The x-intercepts are the x's in the equation. It's where the x, the graph crosses the x-axis. How do you find the x's of this equation? AC grouping, factoring, yeah. This is exactly the same problem that you had on your quiz or your test on Tuesday. So this is a factoring problem. Whenever you have ax squared bx plus c, like factoring is the easiest way to solve this. So if we have negative 16, what two numbers make negative 16 that add to be negative 6 or combine to be negative 6, Ryan? Negative 8 and positive 2. Because there's just a 1 here, you can take those two numbers and put them in parentheses right away. So you could say x minus 8 and x plus 2. You could also use the x squared minus 8x plus 2x minus 16. Like that works as well. It's the same process. So solving for x, you get x is 8 and negative 2. So my x-intercept would be an 8 and a negative 2. They're ordered pairs because they're points on your graph. It's where the graph crosses the x-axis, so it's going to be a point as an x and a y.
These ones, do you have to check if it's an x-ray solution?
No, because it started out as x squared and it's still x squared. So it's when it starts as an x, but we have to change it and it all of a sudden becomes an x squared because we squared both sides. So extraneous solutions are absolute value equations and the radical equations. Those are when the extraneous solutions happen. Alright, so if you look just right underneath this, well maybe not right underneath it. I wanted to go to 43. Is 43 at the bottom of the page or at the top of the next page?
In the middle.
In the middle of the next page, okay. So in this group it says to solve the following equations. 39 and 40 are both factoring. So 39 and 40 you would factor. 41 and 42, you're isolating the x squared, just like we isolated the radical in this current chapter we finished. So these two are factoring. 41 and 42, you need to isolate the radical, or isolate the x squared. So 41 and 42. I'll give you a little bit of a hint there as to how to approach those problems. 43 is set up slightly differently because the 12x is on one side, and then we have 2x squared plus 11 on the other. Because this looks like 40 and 39, and they're equal to 0, you need to set this one equal to 0 as well to try and solve it. And that's because it has that same format, an ax squared, a bx, and a c. So if you have that ax squared bx plus c, that's what it should be equal to 0 to try and do something with the problem. So take the 12x to the other side. What do you notice that all of these have in common? Sam? A 2. So we could take out a 2. And then you can try and factor it, but if we try and factor it, we have a 1, and the only factors of 1 are 1 and 1, and unfortunately there's a negative 6 on the inside. So if it doesn't factor, what equation do we know that we can use to solve it? Sam?
Isn't it like we divide this number in half and then multiply it by, or square it,
So you could use completing the square, that's what you're talking about. So if you said divide the number in half, multiply it, that would be one way you could solve the problem with completing the square. What would another way be that you could solve it, Sam? Do you know the other way?
You could put the 1 on the other side.
So that would be part of completing the
That way,
square.
I don't think I know the other way.
Timmy, do you know the other one?
You break down 6x and whatever it is.
So there's no way we can get it to factor.
It's something big in the radical or something else. And then it's 2ab.
Just 2a.
Oh.
Anybody know what this is called? Quadratic formula. So negative b plus or minus. So the quadratic formula, negative b plus or minus b squared minus 4ac all over 2a. When a problem isn't factorable, that's another way that you can solve the equation. So Sam, you're right. Completing the square is one way. The quadratic formula would be the other way.
Wait, I forget how to do it the other way I explained it. We do it that way.
I'm going to use the quadratic formula because the next one needs the quadratic formula as well. So the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. You can use the small numbers. So you took out a 2. You don't need to worry about the 2. Use the smaller numbers to solve it. So a, b, c, they're in order. B is negative 6, but the b is also supposed to be negative, so that turns into a positive 6. And then it says b squared, so negative 6 squared, 4. And then a is a 1, c is also a 1. You're dividing that by 2a, or 2 times 1. So underneath the radical, you have negative 6 squared times, or minus 4 times 1 times 1. Anybody know what number that is under the radical? Kate? 32. Can 32 be broken down? 16 and 2. So this becomes 6 plus or minus 4 square roots of 2 all over 2. It can be simplified more. So everything is divisible by 2. So your answer becomes 3 plus or minus 2 square roots of 2. So if you look at the next problem right underneath it, it's a little word problem. A rock is thrown from the top of a tall building. The distance in feet between the rock and the ground seconds after it's thrown is given by this equation. Negative 16t squared minus 3t plus 1032. This is the height of the building. That's that last number. That tells you how high the building is. So it's a pretty tall building, 1032 feet. And in most buildings, like you figure our ceilings here, probably about 10-foot ceilings. The door's frame is usually about 7.5 feet. So it's a pretty tall building. We want to know how long the rock is in the air if it's 175 feet from the ground. So it's not like clunking somebody in the head, thankfully. It's magically stopping at 175 feet above the ground. Which is pretty cool that it magically can do that. But the 175 gets plugged in for which letter? Caitlin? The D, because that's the distance it is from hitting the ground. So it's still 175 feet in the air. Our goal is to figure out T, which is time in seconds. So if you plug in the D, 175, negative 16t squared minus 3t, and then 1032. What do you think you need to do to start to solve this problem? Caitlin?
Subtract 175 from both sides.
Yeah, we need to subtract that 175 from both sides. Set it equal to 0. So 10,000 4,000 or 1,032 minus 175 is
957.
957? 857. And then again, this is another quadratic formula problem. So you have your A, B, and C. The numbers are going to be a little bigger. But it gives you a second chance to practice that quadratic formula. So 2 problems in a row there are involving the quadratic formula. So I'm going to let you can finish that. Are there other questions that you wanted to ask for today? Sam?
Should we try doing 43 as the
I'll come back and show you.
What?
I'll come back and show
Okay.
you. Other questions? So you have 10 minutes to continue to work on these problems.